Welcome to WAYSOM. Today this whiteboard explains floor and ceiling functions, rounding rules used heavily in programming, billing and mathematics. Stay till the end because negative values often confuse students. Begin at the top. The floor function gives the greatest integer less than or equal to a number. If you look at 4.6, the floor is 4 because that is the largest integer below the value. For negative values, notice the example -2.3. The floor goes down to -3 because -3 is less than -2.3. This is a common exam trap, highlighted here. Right below is the ceiling function. It gives the smallest integer greater than or equal to the value. So the ceiling of 4.6 is 5. For -2.3, the ceiling rises to -2 because that is the nearest integer above the number. Move to the comparison table. When x is 2.2, floor drops to 2 and ceiling rises to 3. When x is -1.8, floor becomes -2 and ceiling is -1. When x is exactly 5, both floor and ceiling are 5. Tables like this help practice the idea. Now examine the graph sketches. Floors create downward steps with sudden drops at integers. Ceilings create upward jumps. Each step shows closed and open circles indicating whether endpoints are included. These discrete jumps make floor and ceiling easy to recognize visually. Next, examine the uses listed: billing systems round up cost slabs, algorithms allocate buckets, threshold limits approximate values. Floor and ceiling functions give logic to rounding situations. Finally, read the summary. Floor means round down, ceiling means round up, but be careful with negative numbers. If this visual explanation helped you understand floor and ceiling functions clearly, save it for revision and subscribe to WAYSOM, the way to wisdom, for more clarity-based learning.